In this lecture, which is the third in the series on cloud computing for Internet of Things, we are going to specifically focus on issues of service management and security. So, we will look at some of the issues with service management and security in this lecture, and we will not specifically get too much deep into how to offer the service management and how to secure the systems. That will be basically out of the scope of this introductory course on Internet of Things. So, we will simply try to focus on the issues that are there and which have to be taken care of while dealing with cloud computing, and particularly more specifically of cloud computing for IoT. So, let us look at some of these different issues. So, before that, we have to be careful about few things. So, when we are talking about cloud computing, we are essentially talking about service offerings, computing services being offered. And when we talk about service offerings, we have to ensure that there is optimal performance that is delivered to the intended customers or the end users, and there is on demand whenever there is required. The services are offered in an efficient manner in a virtual environment, because as we saw in the previous lectures on cloud computing, these are environments which are virtual. Cloud is essentially a virtual environment where computing resources are offered through the help of virtualization technologies. So, basically the aim is to provide equal importance to desired outcomes of customers through service management, so that the customers are satisfied, and so that there is the customers get the services in a good way at no extra cost and with minimum risk. So, minimum risk means, I will give you an example over here. Cost is understandable, but risk basically refers to that, let us say that customer was using some computing resource, and if due to some reason that resource becomes unavailable, there should be the risk mitigation technique should ensure that there is some additional physical resource which will be mapped to the virtual one that the customer was using. So, that provisioning has to be done dynamically, and the customer should not feel that something had gone wrong, and because of which this change happened in the background. So, basically it is required to offer different types of services, and services including usage monitoring and billing. There should be complete description of clear and complete description of the services that the customer is going to get. Then issues with respect to availability of networks and connectivity, and it should be available continuously. High availability of networks and connectivity should be there. There should be ease of access to these resources, and it should be managed. The services should be managed in such a manner that the customer will not be able to get any feeling of any underperformed computing environment. There should be portals for service selection, there should be service guarantees, and rapid fulfillment of resources or decommissioning of resources should be there, and it should be a secure environment where securely computing and storage facilities are made available to the users. So, what is this service level agreement? So, service level agreement, as per definition, is about non-functional requirements that are expected from the service provider, more specifically the cloud service provider, and this service level agreement, in short, in the industry it is known as SLA. This SLA basically is required to provide a roadmap which will give clearly defined deliverables. So, this SLA will typically describe the quality, the utility, the warranty of services that are expected by the customer. So, this SLA will be some sort of an agreement and handshaking platform between the service providers and the customers, so that the customers know what level of services the customer is going to get from the service provider. Accounting and billing, which go hand in hand, are very important. So, basically based on the resources, the use of the resources and the information about such use, it is required to bill the customers. It is required to bill the customers, and keeping track of this information about the resource use, which is typically in the form of records, the customers will be billed, and the customers will be having, they will be billed based on the accounting records, the resource prices and the billing rules. There has to be some rules based on which the customer is going to be billed. Maybe this much unit of resource consumption will lead to this much billing rate, a higher amount will lead to another higher rate, and so on. So, like this, there has to be slabs or some billing policy, some billing rules which has to be agreed upon between the customers and the service provider. So, accounting records which has to be kept track of, which is a core component of the accounting module. The resource prices, that means what is the unit cost of each of these different resources, and the billing rules, that means what is the policy by which the customer is going to be billed. So, all these taken together will be used for billing purpose. Now, traditionally data centers were used, or even simple IT infrastructure used to be used in the companies, in the organizations. Now, we are talking about replacing such things or supplementing such traditional regular IT infrastructure based or data center based platforms with cloud. So, we are talking about that. So, let us compare with respect to different criteria. Now, for example, with respect to the hardware, the traditional data centers used to use heterogeneous hardware, different types of hardware purchased through different means, different groups purchasing and so on and so forth, heterogeneous hardware with network computing and remote server. So, typically what would happen through a remote environment, this remote networked environment, these heterogeneous hardware would get access to a server, and that used to be the traditional way of getting access to different computing resources. Getting access to remote server means, like, data centers would be hosted remotely, and through this hardware and the networked environment, the users are going to get access to the servers and computing needs, etc., etc. That used to be traditional. In cloud computing, we are talking about off premise resources with virtually hosted solutions, with heterogeneous hardware, software and networks, everything available on the cloud. Whenever things are required, whenever users have requirements, they can easily scale up or down the resources. The resources are going to be made available to the users as per the requirement through a virtualized platform. So, there is some difference, as you can understand, between the traditional data centers, traditional IT infrastructure in the companies and the cloud computing environment. There are different other differences as well, which we have already understood in different perspective in the previous two lectures on cloud computing. One is the differences in resiliency and elasticity. So, cloud resources, cloud platforms are available in an elastic manner, resilient manner. Resilience means that something going wrong, users will not have a clue of it, and it is taken care of, the problem is taken care of. It is resilient to different kinds of failures and so on. flexibility and scalability, you need more resources, you just pay for it, you have the resources with you whenever you need. Automation is understood, running costs, security is very important. Security is, in the cloud environment you have more security compared to the traditional data center or regular IT infrastructure based environment. And with respect to running costs, I have already explained before, so I do not need to explain further. So the running, so here actually you have running costs compared to the traditional one time cost or periodic costs in the traditional data center environment. So here you have running costs, right? So you need more resources, you pay for it, you need even more, you pay even more, and so on. So running costs have to be taken care of in the cloud computing model. Now the economics of scaling, which basically benefits the users enormously, and the economics basically depends on 4 customer population metrics. Number 1, the number of unique customer sets. Number 2 is the duty cycle of the customer set. Number 3 is the relative displacement duty cycle, and number 4 is the load of the customer set. So all these factors basically help in coming up with ideas of economics of scaling. There are different economic incentives for cloud computing, lowering the cost behind infrastructure and computing required in the organization. Then capex free computing, cap free computing, exclusively made available to the customers, deployment of projects faster, that will foster innovation as well. Then scaling up or down as and when required, lower maintenance costs, resiliency and redundancy. Steps in evaluating the database manager. So database management is very important. You need to manage the data in the cloud. So there are different ways of doing it. So we will not get into too much of thing, but we need to understand the saliency behind this particular issue. So it is required to define the type of application that will be served, like the data asset protection, business intelligence, e-commerce, etc., and determine how suitable these applications are for public and private clouds, and the factors that are affecting the easy deployment process. The demands of cloud database management system include efficiency, fault tolerance, adaptivity to heterogeneity, operational comfort on encrypted data, and the capability of interfacing with different products and solutions. So this basically is quite explicit, it is quite understandable, each of these, so we do not need to really dig into them in further detail. So for managing data in the cloud, we need some kind of service like database as a service, DBaaS. We need something like that, and that has to be integrated with the cloud platforms like Microsoft Azure or SQL database. So SQL database basically comes with Microsoft Azure, or with Amazon Web Services with the help of DynamoDB, relational database service, and so on, or in the case of Google Cloud SQL, taking help of database as a service like platforms like Google App Engine Data Store, ClearDB, database.com, and so on. So these are the different platforms, database as a service platforms, that are available through commercial or open source mechanisms for use with cloud. Now let us come to the issue of security, which is the second part of the lecture, and here basically we have to be careful, because when you are talking about cloud, you are essentially handling different types of data, and not only different types of data, these data are going to be stored in different servers, different platforms, which may be geographically distributed, without the cloud user even having a clue about what is going on behind the scene, where physically the data is going to reside, the cloud user does not know. So data security is very important, and overall the security of the cloud platform is very important, because otherwise the customers will have lot of concerns which will affect directly or indirectly their use of cloud services. So, the problem is that the user in a cloud platform would essentially lose control of the information that is available on the public cloud. So, concerns more specifically about the loss of data, seizing of the account, service traffic hindrance, vulnerability of APIs are paramount in the case of cloud and the security of cloud. So, these security concerns have to be taken care of in addition to any other IT security issues that you already know. So, the solution is to have counter security solutions, platforms, APIs, applications, software, etc., which will protect from theft, leakage of data, deletion of data accidentally, by providing security policies. So, security of cloud infrastructure must be implicitly assured for public or private cloud for services such as SaaS, PaaS and IaaS. Building levels of viewing, evaluating and executing infrastructure security include network level security, host level security and application level security. In the case of public cloud, we have to ensure that the small change does not severely affect the network topology, and there has to be proper access control for using resources. So, this is a network level issue and that has to be ensured. Second thing is achieving character traits like confidentiality and integrity of data in transit to and from cloud service provider. So, confidentiality of data, see, as you know that data confidentiality, integrity, availability and non-repudiation are very much important issues in the context of security. So, achieving at the network level, achieving confidentiality and integrity of data in transit, data flowing into the cloud and coming out of the cloud has to be ensured by the cloud service provider, and the security, rather the confidentiality and integrity of it. Availability of internet resources correctly to genuine users from the cloud service provider is another issue of concern at the network layer. At the host layer, issues particularly at the PaaS and the SaaS level include hiding the host operating system from the end users and ensuring to delegate security responsibilities to the cloud service providers. Host security at IaaS level include the objective of securing the allocated hosts with the help of different software, etc., to ensure that attacks such as the blue pill attack on the hypervisor, which is a core component of IaaS platforms, is mitigated or is taken care of. Blue pill attack, as you may be already aware, is a specific type of attack on the hypervisor, and hypervisor is what I have already explained in the previous lecture on cloud. So, hypervisor, the virtual machines sit on top of the hypervisor. Hypervisor is tasked to manage these virtual machines. So, blue pill attack is a very popular form of attack on the hypervisor, and that kind of threat has to be taken care of at the host level. At the application level, both the CSP and the customer are responsible for security at the application level. So, it is here specifically the application, at the application level, not just the CSP, the customer also has to take care. So, if it is a SaaS provider, SaaS cloud service provider, taking care of the security of deliverable applications is their should be their main focus from a security perspective. For PaaS providers, security of the PaaS platform, that means the platform which is offered as a service for development, etc., Google App Engine kind of environment, its security, etc., has to be taken care of. And the deployed customer applications, security of the deployed customer applications. So, that is also another concern. At the ES level, ES providers level, the application level security is not provided by ES. Customers arrange for the security mechanism themselves. So, customer has to take care of the security themselves. Data security has different objectives and the corresponding issues. Objectives include ensuring confidentiality of the data, integrity of the data, and availability. What does confidentiality means? That the data should be confidential and should be made available to only the intended stakeholder. Integrity means that the data should not be tampered with in between, that means when it is flowing into the cloud or coming out of the cloud. And availability means that the data should be made available as per the service level agreement to the intended customers in a secured manner. So, the different solutions include using identity management techniques, encryption, access control, and so on. So, there are different aspects of data security: data provenance, data in transit, data at rest. Data at rest means the data that is used for long term use, that is data at which does not change too fast and it will be there in the server for long term use in the future, and so on. Data including multi-tenancy and the data lineage. So, data lineage means data lineage, data remnants, and data provenance. These are the issues with the data. So, data lineage means like from the start, from the source till the data is used, ensuring the security of it. Okay. And similarly, the data remnants basically takes care of that whenever the residual data, etc., securing that data, keeping track of that data, that basically has to be taken care of. So, like this, actually these are the different issues of data security. So, let us first talk about identity and access management, IAM, which is basically a branch of cloud security that allows the legitimate persons to retrieve the legitimate resources at legitimate time for legitimate reasons. So, legitimate persons retrieving legitimate resources at legitimate time for legitimate reasons is basically the issue, the main issue behind identity and access management in cloud security. Here the user identities and the access permissions are instigated, caught, administered, and recorded by IAM, that means the identity and access management module. Authentication, authorization, and evaluation of all resources are done according to the terms and conditions and the roles of the users. Features of this module include single access control interface, increased security, access control over resource level, improvement of operational efficiency, organizations attaining access control and operation security using this module, and improvement of regulatory compliance management. Access control is very important in cloud. So, service providers have to take care of it explicitly. So, access control layers in cloud include cloud access, server level access, service level access, database access, both directly and indirectly. Directly, the queries should be sent via web services, so taking care of that, and VM access, virtual machine level access, access to objects within a virtual machine. So, these are the different levels of access, and the control of the access to these different layers has to be taken care of. Management of these layers depends on the provider or the consumer based on the deployment model. Trust and reputation are very important. Trust basically takes care of issue of independent expectancy between two entities for any specific context at a given time. Independent expectancy between two entities. So, they have to trust each other. and at the same time hand in hand comes the issue of reputation, and reputation is about the belief of an entity standing on the community. What does the entity have, what is its reputation in the community. So, these are the two different issues that goes hand in hand. So, these concepts are needed by the customer to select appropriate cloud provider. So, there are different models, or sorry, rather different modes of trust establishment. So, these include accomplishment of service level agreement. So, whatever service level agreement exists, accomplishing it, then application of the audit standards that are out there, whether the audit standards have been adequately applied or not, measuring and rating, and questionnaire for self assessment. So, these are the different levels of trust establishment that has to be there. Risk assessment, categorization of different assessment methodology, formal versus informal procedures of risk assessment, qualitative versus quantitative methods of risk assessment. Qualitative means that high risk, moderate risk, low risk, versus quantitative means numeric risk figures. Consequence versus cause analysis. So, whether the risk is due to a consequence of something, or what is the cause behind the risk, and inductive versus deductive techniques. So, these are the different categories of risk assessment in cloud. Authentication in cloud computing, user authentication. So, there are different aspects like where user authentication process, which takes care of the user authentication process between the new users and the service provider, when during the authentication the properties and the safety of process which can be invaded by attacks causing severe damages, and where the user authentication is done at the patch layer, and the consequence is threat to authentication process can lead to divulging of confidential data to a fake user. So, with this we come to two broad main issues in cloud computing. One is taking care of the service management with the help of SLAs between the customers and the service providers. Number two is this issue of security, security of infrastructure, security of the platform, security of the software, and the data security. Data security is very much important. Customers, they do not know really that where their data is going to reside, how the data is going to flow around in the system, and that has to be assured to the customer that their data is going to be safe. So, taking care of measures to ensure that there is enough security of the data and the parties can trust each other, that also has to be ensured through the process of some kind of reputation tracking, and ensuring that those reputation measures are basically disseminated for developing trust between these different parties. So, all these things have to be ensured in order to meaningfully use cloud in a commercial or any kind of environment. Thank you.